Hello students, in today's class I want to go over the rules of the exponents, the properties of exponents and properties of logs, and draw some analogies between them. This will be really helpful because this is the main crux of math actually. So let's get started. So the product rule here, if this is for exponents, we'll come to logs in a bit. We'll first do exponents. So the properties of logs, properties of exponents, you have the first rule as the product rule, which says a to the x times a to the y is a to the x plus y. To explore on it, actually, you just take simple examples with 2's and 3's. Like, suppose I have 2 cubed times 2 squared. What would you do? Normally you would expand it, right? You would say 2 cubed is 2 times 2 times 2, but 2 squared is again 2 times 2. So how many 2's are there? So 2 is multiplying itself 5 times. So you would write as actually 2 to the 5. I know it is 35, but I'm just saying how many 2's are there when you are doing this kind of product. So if you actually see, 5 is an addition or a sum of 3 plus 3 and 2. 5 is 3 plus 2. So that's what is happening here, right here. So a to the x times a to the y is the sum of the exponents, a to the x, provided the bases are same, right? A and a, the bases are same. And also we have to also note that a cannot be 0 and b cannot be 0 as we go. The quotient rule, if you take an example of quotient rule here, so if I say 2 cubed divided by 2 squared, then what would you do? You would do 2 times 2 times 2 divided by 2 times 2. So some of them will cancel and you're just left with 2, which is 2 to the 1. So if you actually see, 1 is a difference of 3 and 2. 3 minus 2 is a 1, and that's why we have here x minus y, right? We are subtracting the exponents. Sometimes x is more, sometimes y is more, right? Even if y is more, you will say to the negative 1, right? For example. So so that's one thing. That's called the quotient rule. That's the quotient rule. Now if we see the power rule, which says a to the x to the power of y. So what does that mean? So if I have 2 cubed to the power of 2, so you're actually doing 2 cubed times 2 cubed. That's what it means, isn't it? And if you actually expand each one, you will have how many? 6 of them. So this will be actually 2 to the 6. So what really happened? 6 is a product of 3 and 2. So and when we have power of product rule, we can take another example like this. Now there are a and b, so there are 2 different things here. If I had 2 times 3 to the power of 2, for example, this would actually mean that there is 2 times 3 times 2 times 3. But in effect, how many 2's are there here? There are 2 2's and 2 3's. So what really happened was this 2 in the exponent was distributed on 2 and 3. And that's what this means. So a to the x times b to the x. And likewise for power of fraction rule, that's what happens too. So if you have 2 divided by 3 and square, so this, what it means is it's 2 over 3 times 2 over 3. So what will that mean? It means that there are 2 squares and there are 3 squares, meaning there are 2 3's and 2 2's, but they are just like distributing over, right? So that's the power of fraction rule. It's the same product rule, except for that this is a product and this is a fraction. That's the only difference. When it comes to zero exponent here, a to the 0, anything to the power of 0 is 1. Infinity to the power of 0 is 1. So that is really important. And but this actually plays a very significant role. Negative exponent, if you have 2 to the negative 3. It means that you have to bring it down. 1 over 2 cubed, that's what it means. This negative becomes positive in the denominator. You have to bring it down. And the same thing works with if you have a negative exponent down here, then it will come back to a positive exponent when it goes up. That's the another way of looking at the negative exponent. And this actually, this is a fractional exponent and this is the equivalent radical. So this is very important when it comes to radicals. Like suppose I have 25 to the power of 2/3, right? What happens is the square here remains on the 25, but the 3 actually is the radical here. It goes into this cup. It's cube root of 25 squared. That's what it actually means. Okay, so these are the exponent rules, and especially these 3 are really important for us to understand the log rules now. So just like how we have exponent rules, we have logarithmic rules. So that's what we're going to do. We have the product property, the first thing. It means that when you have log to the base 3 of 9 plus log base 3 of 5 and they're being added. So when you are actually condensing into a single logarithm, then you will write it as log 9 times 5. 9 times 5 to the base 3. So we have to make sure that the bases are same. This will work only if the bases are same. Okay. So if the bases are different, you cannot. So this log property is log m to the base b plus log n to the base b. Log m to the base b plus log n to the base b. So when you're expanding a product, you have to now put the plus in between them. Whereas what we have seen here in the exponents, exponents and logs, they are inverses to each other. We have seen that previously in the previous day. So see how the exponents are added here. Likewise, here you have to add them here because log is an inverse of exponent. So log m plus log n, that's what it means, and with the same base b, right? So that, and you can use the same thing. You can go from here to here and from here to here. When you go from a product to an expanded sum, then you will actually say you're expanding it. And when you're going in the opposite direction, you're condensing it. This is condensing and this is expanding. Okay. So this is in effect log 45 to the base 3. Right. So let me open the calculator and see and show you that how this works. Hold on. Okay. So if you see here, when I do let me, to make matters simple, I'll just use log, common log. Okay, log 9 plus log 5. Okay, that's the question here. Log 5. Okay, so that is 1.653. If I say log 45, even that is the same value. You understand now? So it's still the same thing. So when you're seeing two logs being added with the same base, you can actually multiply the arguments. That's what is this product property about. So if you have you look at the second question here, you can as well write this. This is common log now, the base is 10. This would be 6 times x minus 3. That's it. You can distribute it or whatever, you can leave it here. Here, this is natural log, that's fine too. ln 4 times 3 is 12 and x squared times x cubed is x to the 5. See how we are also using the exponent properties too now. Okay, so that's how this works. Now when we are asked to expand, you can take any factors of 72. So 8 times 9 is 72, so we could take that. So this is log 8 plus log 9. right? Here, now this is a fraction. So now you are expanding. So you're going in this direction. From here to here. That's the direction we are taking. ln 9 minus ln 10. Okay, because it is subtraction. Why? You can actually look at it this way, but hold on, I still didn't teach you power property. So for now, just take it as subtraction. If you see a fraction, then you have to do a minus. But this we cannot expand. Why? Because this is within the argument, there is a subtraction going on. We cannot write this as log x squared minus log 4 base 5. No, we cannot do that because this is the argument. You can only do additions and subtractions when they are already expanded. And when they are not, so this is a product and this is a fraction. It works only in those cases. Okay. So coming to quotient property, quickly, log m base b minus log n base b. So what we have seen here is here. So as I told you, now we are expanding by writing this. When you're given this, you are condensing to that. So here he is asking you to condense. So this is a subtraction. What you would do is the argument here will go into the denominator. 96 over 6. That's what it means. Okay. You can simplify it or not. So here if you see log 8x to the 10 divided by 4x squared. That's how you write it. Okay. And then you can simplify it. And 10 minus 2 is 8. So this will come to 2x to the 8. Okay. Like so, log square root of 40 over square root of 5. And you can still process this. Base 7. You can put parentheses if you want. This will all come under one roof. So 5 goes in 48 times. So this will be log base 7 of square root of 8. Okay. So when you have to expand, it is simply log 8 is, now there is this just like 8 divided by 1, isn't it? You can write it as log 8 base 3 minus log 1 base 3. Log 1 is at anyway 0. You will still have the same thing. So it's not really expanding it, but we can just say because 8 is 8 over 1. Any number is still a fraction, isn't it? And this is ln 3 minus ln 4. This is log x minus 7 minus log x plus 1. Okay. Now quickly we'll go through the power property. Now power property is really simple. If you have something like this, there is a power here, m to the n in the argument. So this would be n times log m base b. What happened? This power is now coming as a line leader. It goes as the coefficient of this log. So if I say 3 log 6, now you have to do the opposite. You can, going from here to here over this. So you can write it as log 6 cubed. Okay, you can write this as log 81 to the power of half base 4. So this is square root of 81, which is 9. So you can also write it as log 9 base 4. Here you can write it as 4 to the power of x minus 1. Right? And when you're expanding, this x becomes the line leader. So it will be x log 5 base 2. And this you have to write as 2x plus 1 to the 1/3 ln. So this 1/3 comes to the front, and this is what you would write. Okay, I will leave this to you. So this is the properties of exponents and properties of logs to you. I hope this will be helpful. I'll see you in the next video with more problems. Thank you for watching.